Hi everyone, thanks for clicking on this video. What I'd like to show you today is a patented design for a new type of valve that I'd like to bring to market and looking for somebody to partner with. So with that being said, today what I'm going to cover is basically talking about how this compares to existing valves and where the savings exist. So the current problem, and we're going to go specifically talk about globe valves. Because globe valves are the standard for being able to control very precisely, they work very well for that. But what people don't realize is that there is an inherent flaw to every globe valve, and that is the fact that P1 does not equal P2. You have a turbulent flow path. So as that fluid changes directions, and as you have a globe valve that sits in service for a number of years, you'll see the pitting caused by that cavitation due to that critical turbulent flow path. Also requires a multi-turn actuator to be able to automate. Even a hand wheel like is shown here is required to actuate it, which means you're going to need a very expensive actuator. It's going to have to be large, and it's going to have to be capable of being automated. And then you also have that large pressure drop. This means that when you're designing your PNID, going through your PNID, you have to account for the pressure drop that goes through every single globe valve. So here is how it works. A 1-inch globe valve, a 1-inch Eclipse valve, which is the name of my invention, is a full bore control valve. Now, why a full bore control valve? The fact is you can get very precise control and also have full flow as much as the pipe going into it has. What this means is without that turbulent flow path and without the degradation of pressure or flow that's on the downstream side of the valve, this enables you to use a 1-inch Eclipse valve in the place of a 4-inch globe valve. So what that means is if we're looking at more to scale, this is a 1-inch versus a 4-inch globe valve. The differences are pretty apparent, and it's also a very significant decrease in cost, in weight, and the cost of actuation. So let's talk about that a little bit. Now, if we're looking at the cost of a 1-inch Eclipse valve, I'm able to reproduce these in plastic for $5.27. I know the costs of globe valves are all over the place, but they're certainly much more expensive to manufacture, much more complex. They're also more difficult to service in line. So the cost of an Eclipse valve does not equal the cost of a globe valve. We know that it would be significantly less. We also know that it works with additive manufacturing, which would mean that it would be very inexpensive to build. Now also that means that the size of the piping that you're using in your PNID has the ability to be much lower. As we used in the previous example, a 1-inch pipe, a 1-inch globe valve, a 4-inch globe valve versus a 1-inch Eclipse valve have the same amount of flow on the downstream side. This means that skids can be now made much more compact, much lighter, much smaller, much easier to ship. So you're saving on a number of different occasions. We also know it's not going to weigh the same. The estimated weight of a stainless steel 1-inch Eclipse valve is going to be somewhere in the neighborhood of 11 to 12 pounds. I've seen globe valves that weigh in the several hundreds of pounds. If we're doing a direct comparison of what the Eclipse valve can do versus what a globe valve can do, why in the world would you put something that much heavier on your line when it's not necessary and the performance can come from something smaller and more compact? So we know it's lower weight. Now also let's talk about the actuation. Now these are two typical actuators that would be used. The T-crystal on the left is used in a lot of low torque applications. Now the Eclipse valve is very low torque. It's also designed to work with 90-degree actuation. So as opposed to the multi-turn actuator that you see on the right here, the T-crystal small electronic actuator can automate your line with an Eclipse valve, and it's no bigger than the size of most people's fists. So you can use a much less expensive actuator, again saving costs, and now that also means that it's a much more compact system. The actuator and Eclipse valve together are much smaller than the actuator and globe valve together required. Even if we're looking at a comparison of 1-inch globe valve versus 1-inch Eclipse valve, they are much different in size. So let's talk about how I arrived at the design. Before I show you how this works, I've worked with a number of companies that had a heavy interest in a full bore control valve. In fact, it was a design that I had sold. Now, the reason why there is an appetite for a full bore control valve is the fact that the P1 does equal P2. For the reasons I listed before, being able to make smaller skids, being able to use smaller piping, be able to use smaller actuators, adapting something to 90 degrees. However, I looked at a cigar cutter and I said, you know what, this would make a great valve if somebody could just figure out how to actuate this 90 degrees. So that was the initial principle behind designing the Eclipse valve. Now, many of the end users that I was dealing with, all in oil and gas, aerospace, petrochemicals, chemicals, across every single industry, had a very heavy interest in this. But I also found that they were usually used in lower performance applications if they're doing simple water, and that meant that cost was quite a bit of factor. So it had to be something very simple. So inline serviceability and downtime are also big considerations. So I made it a point to make sure that this valve could be disassembled inline and then reassembled within a minute. There are simple 3 moving components to this. So let me show you how this works. Inside the Eclipse valve is a simple pinion gear and 2 rack gears. Now what this looks like from the top, we'll show what it looks like from the sides, is that as this pinion moves 90 degrees, it moves these plates across each other as a surface. What's great about this is there are no elastomer seals, so we're not hindered by the temperature requirements of the line. Now also what I've done is I've baked in a simple 1 degree incline on these plates. So now what it looks like is it does the same thing. However, as these plates move across each other, that 1 degree angle actually pushes the plates up against the insides of the Eclipse valve body. And what that does is it enhances its shutoff capability, again without the needs for elastomers. It creates a flat surface against flat surface with great surface area of the stainless steel, titanium, whatever, Hastelloy, whatever the valve may be made out of. Now, what this means from the front, and this is where the action happens. So again, recall that the cigar cutter idea. This is a fluid path, and this is what the fluid or air or gas sees as it goes into an Eclipse valve and as it actuates. So it works like a cigar cutter with these plates moving across from each other. However, when you put the body on top of it, this is what it sees. So the ability to open full bore and then precisely control the flow anywhere between 0 and 100% means that this is a precise flow control device. The CFD analysis shows that it has a very controlled, easy manner of being able to control flow in a logarithmic manner. Now what does that look like? This is the CFD analysis of CV. So you notice that you have some very precise control over the very beginning opening of the valve. Anywhere between 20% and 40% opening, it's very incremental. However, logarithmically, it starts to increase very much. And you can also notice that the anticipated flow control curve is very, very smooth. There's no jumps. There's no issues that you would have with trying to, say, control flow with a ball valve or something, or a gate valve or something of that nature. So you can hopefully see why it's different, but here is just kind of a summary of it. Let's talk about rangeability. To have the capability of full bore to shut off and anywhere in between is obviously a very big advantage. So instead of having a shutoff valve with a control valve, this can handle the job of both as both a block and a bleed valve. It allows you to have more smaller piping, meaning more compact skids, meaning less expensive to build your skids, less expensive for your customers. And also the zero pressure drop just means that, hey, if I need to open this thing full bore, I can get as much flow out of it as I can the pipe size going into it. Now, the 1-inch valve is also about the size of a fist. It's very, very compact. The 90 degrees of low torque actuation means that we can use small actuators like that T-crystal as opposed to having large quarter turn or even large multi-turn actuators that you see in globe valves. A standard ISO 5211 mounting pad is there, so it's an industry standard to be able to bolt something on. Now, it's also very low cost to manufacture. Now, here's the thing. I've been researching on additive manufacturing, metal 3D printing, The ability for this valve to do that in plastic is there in theory. I'd like to try it in metal 3D printing. However, there's also the possibility of doing investment casting with finished machining to keep costs down of building the valve. The inline serviceability is a great thing. There are 6 bolts to remove. You remove the 3 moving plates and the pinion if it needs replacing, and then you put new ones in. The average time to replace all 3 of these is less than a minute, so your downtime is significantly lower than it would be with a valve that's not inline serviceable, or even a standard valve that is inline serviceable. It takes a lot more effort to be able to rebuild it. So this is what I'm looking for. I'm looking for a company to partner with that's going to be interested in licensing this design from me. And what this means for you is a portion of the market share that's continually growing. Aside from the pandemic, aside from the challenges that we've had with the economy, the valve industry continues to grow. And the reason it's growing is because people are hungry for innovation, they're hungry for efficiency, and they're constantly searching for the next greatest valve design. I think in a market that has not been disrupted in a significant period of time is ripe and ready to take on a new valve design and start thinking about how to write new processes based on the performance of this valve as opposed to using the performance of existing valves. So I think that it's also very well poised to compete with 3 more dominant valve types on the market, ball, gate, and globe. So that's 55% of the anticipated valve market. I really think that this valve can outperform any one of those and can also be seen as a replacement to any one of those. Now, the additive manufacturing possibility, I'm thinking specifically about using it for lower cost applications, making it out of PVC for pool service, so it can go to the very, very low level applications, and also to the very, very high, where high performance control over steam or chemical manufacturing is needed. So out of all the uses that I see for this, and in my experience in the past, these are kind of where I see the main places where this valve would be advantageous. And coincidentally, it's also the same kind of places where you would see globe valves being used. And I think that's probably the first aspect of the market I would go after, is anywhere that there's a globe valve being used. So things like the cooling water systems, fuel oil systems. There's a ton of industries like aerospace and chemicals, and you have a number of textile manufacturers that have lines that are going to definitely need something that is a full bore control valve. They just don't know it exists yet. Now, what's next is I have some aspects of the design that I'm changing. So I'm working with a patent attorney with a continuation in process to make a modification to the design that'll make it even less expensive to manufacture and take away some potential points of wear and tear down the line. So stay tuned for that. If anybody's interested in talking to me more about this valve design and about the possibility of manufacturing it and licensing it with me as a partner, please reach out to me through private message, and I'll be happy to talk with you further. Anyway, thanks so much for watching this video. My name is Chad Heffernan. If you have any questions, please send me a message. Thanks so much.